How's it going, everyone? Euler Gonzalez in a new outfit here. So today, let's going to explore now is the functional programming, because on previous video we have looked at least a little bit of history for context to understand now how do we get here, as a way to everything that we're going to learn now has a little bit of meaning, and therefore that we're going to use emotions, these visceral emotions, not to let us control ourselves, but as a tool when it comes to learn at least these functional tools. And also I will argue that you can use this to your life. Now, why this is important? Because once you, again, I am not a neuroscientist, but emotions through your life most of the times is something that we have that memory. Most of the time when bad stuff happen to us, that is something that is a stick to us. When something good happens, it's also as well, but negative feedback are now rooted deeply into our emotions. So the idea is, by at least recognizing our emotions, to learn something, especially this functional approach of writing applications as a way to now be able to describe that. A lot of the time we're gonna get this stuff faster than ever. Now, yesterday we went through, describe a little bit of history with the evolution of software architecture, as well as a very interesting video of the Woven of the Loom of Sorrow, the history of computation. Both of them now hosted by Grady Butch, all right, the coevolution of computer and conflict. That's interesting. Let me put it here. The coevolution of computing and warfare, and conflict. The coevolution of computing and conflict, right? And here that initially, because on the Muslim golden age we're talking about is 10th and 11th century before after Christ, is now when the city of Iraq, or the country of Iraq, a city known as the House of Wisdom, is where all of these different people gathered together, and now they develop or recognize particularly words that we are now using. That, for example, algebra, or the ability to now break in complex stuff into small chunks of stuff, right? As well as algorithm, this series of steps. So this is not a lonely journey. This has been the collaborations of a lot of people that, in combination with a lot of thinkers, free thinkers, philosophers, mathematicians, and people alike, now in combination with the people of power, they have now seek applicability and advantage of now not only dominate the material world, but also to explore is the patterns on nature. So moving forward, jumping forward to today's days. Now, if you allow me to explain at least briefly how do we get here, in terms of, with the House of Wisdom, we now have this particular concept, definitions that allows to do stuff, for example, algebra and algorithms, and how now in the Middle Age, at least in Europe, how all of this stuff were used on the work as a companion of work, All right, so Da Vinci created a lot of these mechanisms, and most of them wouldn't see the light, but few of them they did indeed. Now, with the advancement of the industrial age and all of these steam engines and calculations that sailors need to do in order to locate themselves into the stars and find a ways to navigate through concept like logarithm from James Napier, and then now computations needed to or all of this tedious computation that needs to be done over and over and over in order to get that result. Then with the 20th century, which now all of these different alliances with the state back them, whether it's with Prussia, Russia, Germany, and French, and United Kingdom, Spain, and also from the Slavic countries, what is known now as Kosovo or Yugoslavia, right? So with the kill of Archduke Franz Ferdinand, now this trigger is a ripple effect through all of the alliance, and therefore now the World War I actually now create this initiative to use now the mathematics and scientific methods to see how we can dominate others. But it was not until the Depression, the Big Depression and the Second World War that was used heavily as an instrument in conflict, in warfare. So this is the moment when now computations and brilliant people from the Axis and the Allied forces, as they like to call, develops techniques and mechanisms, and one of them is from the Allied forces. One of them is Alan Turing, a brilliant mathematician that actually, in combination with others, they now create and broke the Enigma code, this encrypted message that was defined by that was created by Germans, and that actually now leads to the what we know is the D-Day, and therefore is now the Allied forces getting into Europe and now start to liberate Europe from the domain of fascists, in this case from Hitler forces. And also in the Nazi Germany, there were some advancements there that was happening, especially in terms of the computation. For example, like computers like C1, SUS, I think it is C1 computer, right? Or the SUS computer, C1, C2, and C3. That was developed let me put it here in English. There you got it, because that was in Spanish. That's quite interesting. Konrad Zuse was a German, that actually developed that. So the idea here is that by exploring that, now the computation that was now used as an instrument of conflict it is quite interesting because after the Second World War and all of the people that actually now give their life to be part of this, to part of the idea of defending the freedom for the rise of fascists, when they come back to home, now companies from the defense sector and also from the consumer sector like Rand now created initiative to actually create geographical systems to help them now position is all of these different missiles where they can now move across the country and then guarantee the mutual exclusion, guarantee the mutual destruction assurance. So because now moving forward to the 60s and 70s, the 60s, when the USSR launched Sputnik, that was a moment where now the US say, oh, we didn't see that coming, snap. Oh snap, we didn't see that coming. And that is something that back then with the DARPA, okay, this agency for advanced, how do you put it there? Defense Advanced Research Project Agency arise with the Eisenhower in 1958 as a way to avoid any surprise in the future. We don't want to get caught. We don't want any kind of surprise in the futures. And this now leads to the birth of the internet, aka the ARPANET, as a precursor that bore in the fence, and now we have inherited that and we have that in the consumer field, which is, that's what we have here. Actually you are see me here recording all of these kind of videos, and Jesus, this is interesting, and you can even reply in the comment section below to say any stuff that you want to, or describe my hair, or mocking of myself, or even now write some very insightful comments to the topic. So, but in any case, this is something that now with war and computation, how now they tightly closely related to that. And in the computer and in the history of computer software architecture, which is in the 1960s, right? That by the time that the way how we decompose processes were through algorithms. So we have now the structured language like COBOL and Fortran among others, that they are doing the specific stuff for specific things. So because now with the rise of other technology developed and invented, like time sharing, so we not only are capable to construct our applications in a single powerful machine, but we can also now delegate that task to other computers. Now the idea is that with this distributed computers come up with different challenge. This is now the asynchronicity aspect of developing applications, but here we are looking is at the provable way of writing our code that work as supposed to. So we don't need to go back to actually make sure that our code actually work as expected. And this is now that functional programming is being used as well, because right now with the issues of maintaining applications that are multi-language, they can run in different computers in a distributed way with different purpose. They come with and there was a lot of language out there to actually try to compete in that landscape. So a small talk, a language called Smalltalk, that now was the first to incorporate all of those ideas, an idea of abstract syntax, abstract data structure, in the way of how you can hide informations inside of this data, and it's looking now at the way at different lens. So instead of looking at the systems or these processes as, or the world as processes, let's going to take a look now at atoms, and that's where we have now classes here. Now this class, or this Smalltalk, or the Bush methods, actually makes a lot of sense, because now this is a way of how you can describe the real world to now allow us to create systems to replicate that in the real world. However, one of the things that, according to Grady Bush, and I assume that is also I don't have that vast experience that Grady Bush mentioned, but so far with the inheritance of, because I have inherited a lot of older code bases, and the problem that I see, especially with this object-oriented programming, is the emphasis, is the overemphasis on the inheritance. But in any case, because this is a course where we're going to look at the value proposition of the functional programming, okay? And I hope you don't bore you to death with all of the stuff that I mentioned before. But the idea here is to try to describe all of this in suing this particular history. So once you go out there and try to understand, make sense of what you do in the stuff that you do, now it makes sense, especially for any industry that you want to work with. That at the end of the day, most of the times, this kind of softwares are things that are applied to war, and this is when a lot of the benefits has been made and the progress has been made, so now the consumers can enjoy that. So functional programming, when it comes to write this kind of applications, the value proposition of this is because we don't need to mathematically prove that 1 + 1 is equals 2 to go on into our life and work with that, use that. We, most of the time, what we want to do is that the fact, and 1 + 1 is equals 2, and then we want to, whatever stuff that we want to buy or sell, or even to count, we want is any time you do basic arithmetic, you don't need the mathematical proof to do that. So much of this particular course is focused on that, according to Kyle Simpson, which is the front-end master and also the author of books like You Don't Know GS and the Functional Light Functional Light JavaScript, which is this particular course is all about, and also is to recognize that functional programming, okay, it's not a solo journey. This is something for those who are curious about, or they at some points needs to understand that, because at the company they say, hey, we need you to actually go and apply this kind of stuff, and you barely use it, you feel behind in your industry, But this is something that's pretty much like you are doing rock climbing. I have never done rock climbing. I mean, not professionally, but when I have 9 years old, I really love to do that rock climbing. Back in my town, there was a 3-meter stone, 3-meter bauxite, I think is this. Yeah, 3-meter stone bauxite. Yep. Yep, absolutely. Exactly. So back in my hometown, there is now a stone. There is a park where the middle you have now a stone, the first 5 stone, 5 bauxite stones. This is known as. Oh, I mean it's iron. Okay. Venezuela. This one, right? I think we can take this one. Exactly. So, what? For instance, so back in my hometown, that's right. You know, this is a well. But back in my hometown, there is a park known as the Iron Park, where it has this particularly small monolith of irons where you can do rope climbing. Why am I mentioning this? Because pretty much like when you are doing rock climbing initially, that you don't know a lot of the equipment that you need to wear to do that. Those who are now master veterans in that field, at some point they don't when they understand concept like monads in the case of functional. So once they know all of this, they stop teaching. They stop. They stop teaching. So the idea here is that not only recognize that as we move on, as we progress in this functional programming paradigm, it's something that is not a solo journey, because you need to also convince other developers in that journey to use this functional approach. Why is that? Because the point of this, unlike the imperative approach, which is something that we're gonna go, this course is the core is going from bottom up, unlike most courses that start from top bottom, where here we're gonna see what we are work with, the imperative approach, and then on top of that now build our knowledge as we now make the transition to a more functional approach. So the TLDR is that even though that imperative code, which is something that we know for sure that works as expected, because we are describing how things work, and that is, hey, if you tell a friend to go out, if you're organizing a party, you tell your friends, hey, go out and buy beers and ice, right? You don't have to explicitly tell all the set of instructions that he needs to do. You just tell them. And that's exactly with imperative programming, even though that this is quite performance. But the cost is readability, because despite that you might have write that code, or you wrote that code, some other people, some authors, when they read that, they need to actually dedicate time to understand what that code does, and then is when the code becomes harder to debug, to understand, and to improve, to fix. It takes times to do that. Well, now with the declarative, the only thing that we want, or the focus, is on the output. what this functions returns and why, you know. So it is more descriptive about it. So this function might do a lot of inner stuff behind the scenes, but at the end of the day, when we want to use that, we just want is to know what give us and why it do that. So this is part of the value proposition of the functional programming, that now code is provable. So you don't have to, pretty much like when you're doing testing, this is the reason why we're doing testing. So because we have now the guarantee that our code won't break behind or back, which is awesome. But now with functional approach, since we are describing now a narrative, the idea here is to be as much as descriptive as possible. And if you want to use that tool, well, you just care only about the outcomes, or why am I using this. So there is now a functional journey where they mention here. It's like, hey, here we're going to see now that the more you are learning this, or you can learn a lot of this imperative code, and when you learning of functional programming begins, now this is called as the pit of despair. Okay, and also recognize that there is a tension as you move on to the clarity and apply that into your code to go back to what you are familiar with and therefore improve that. So these two stuff, the pit of despair and the tensions that are when you are going to write your code, is something that is going to be there a lot. In you need to understand that the more you keep pushing, the more you are going to understand, and the more aha moments will come up. So this is not something that it will pop up from one miraculous stuff that you might do, but understand that as we move forward, we want is to see what is the value proposition of this, which is the next topic here. Code is provable, right? Code is provable. And let's get into this.
This is more from a mathematical perspective.
So this is more from the mathematical perspective. Good.
Functional programming, though it looks very programming-esque, it looks like function calls. It's actually math.
Functional programming that looks like functional
programming, though it looks very programming-esque.
That looks like programming-esque. is a way to say in Spanish is programmability, programmable. Oh my God, Spanish and English is messing with me. Programación funcional, programabilidad. You know? Okay. Programming-ish.
It looks like function calls.
So it looks like function calls.
It's actually math.
So it's actually math. This stuff, and I love to use this word, the mathema, when you go and understand the origin of words and how that word means, and what that works means. The mathema, when you trace back to its origin so far, on the Greek, mathema means is what one gets to know. So the more you are exposed to that, the more you are now see things and recognize those patterns, and it is up to you to apply that in real life. So move on.
Now, I don't know the math, and I guess that at least some of you don't know the math either. But you know what? That's okay. This isn't the math course. I don't need to teach you math for you to benefit from it. Here's why. I'm sure all of you at some time or another, probably recently, have eaten out at a restaurant, and they brought you the bill, and you had to do some basic arithmetic to figure out what tip to have and how much you were going to charge them. Okay? Now, you probably learned, most of us at least, probably learned basic arithmetic back in first, second, third grade, something like that. And you've been using those life skills ever since. And I'm also willing to bet that the vast majority, if not all of you, have never actually gone through the formal proof of why 1 plus 1 equals 2. You've never gone to that level of math. Did you know that there's an actual formal proof for it? And did you know that it's amazingly complex to prove that 1 plus 1 equals 2? I can't even begin to explain the math to you. I'm not a good shot. The point is that we're able to take advantage of a mathematical principle even if we can't prove it to ourselves. We can add 1 plus 1 equals 2. And guess what? We never ever question 1 plus 1 equals 2, do we? Is there ever been a time where you were like, well, I added 10 and 9 together and I got that? Is it really? Like, no, you just do it. So when I tell you that functional programming is based on mathematical principles, you can rest on the fact that if you do 1 plus 1 and you get 2, that's the end of the story. The math proves it. Whether you can go through the formal proof or not is a secondary issue. Functional programmers, by the way, seem to get a particular joy in life from going through the formal proofs, and that's totally okay. But it didn't work. They seem to get a
Functional programmers see a joy in life.
Joy in life from going through the formal proofs.
Exactly. Functional programming see a joy in going to the formal proof. Yeah, functional programmers see a joy in going into the formal group.
And that's totally okay. Where to learn a thing means I need to go learn some mathematical laws and apply it, do some notations, equation. That isn't how I learned this. And yet I can still take my fun. Do a test, you write some code, get the test to run, and we're trying to get it to pass. Some universal experience. Here's what happens for me. Maybe it happens for you. Hopefully, well, maybe. Let's see. Nope. What do? I go back and I wrap some parentheses around something. I try again. Nope, didn't work. Okay, and then I add 1 to it. Nope, didn't work. And I just keep fumbling my way through because
Fumbling my way through me. I write some code and some tests, crossing fingers that works as expected. All right, and it failed. So then I go back to the code, fumble upon that, fumble myself upon that until it works. It is time consuming and not a very wise use of my time. Wouldn't be better, exactly, wouldn't be better to know how this stuff works first before actually there's no first, so any time I need to do something, it works the first time.
What would it be like? What would change in your programming, in your profession, your day-to-day work? If almost every time that you went through a test, you were 100% certain. What would that do for you? Would you spend less cycling?
So what would you do if your cycle is that what will you do if you do tests, you'll be 100% accurate of the outcome. You will spend less cycle. You will spend less cycle knowing how to fix stuff and more on what is important to the business.
What would that do for you? Would you spend less cycles trying to fumble your way through figuring it out? It offers the promise of rules and principles of programming. Not that somebody just wrote about it in a blog post or but it's based on real hard math. Even if I don't understand the math, I can trust the mathematician. I'd like to have more of my code like that. I don't know about you, but I'd like to have more of my code in that category of, I guarantee it's going to be very important. Things, logic, and business domain questions you should spend your time on. But it just happens to be the programming that happens. The best code is the code that didn't have to be written. And that might sound a little strange. There's a lot of different things that people will say about what is the best code. That might sound a little strange to me. But let me explain this. There's a code base that is 10,000 lines of code. What if 9,900 lines of that code was based upon proven mathematical principles, and I didn't ever have to second guess any of that stuff? And there were just 100 lines of business logic code that I spent all day, every day thinking about. Would that code base be more effective for me to manage? Would it be easier for me to find and fix bugs? If I reduce the surface area of what I need to focus on.
Since the code is based on mathematical principles.
These ideas can help me. We have that in a conversation.
I can focus my attention to what was really important, the business logic. So, well, that'll be all for this video. Take care. Bye-bye.